Good morning, everyone.
Good morning.
Oh, goodness, that was terrible. Are you tired already? Let's try that again. Good morning, everyone.
Good morning.
Amazing. I still think you're a little bit tired, but we'll change that very soon. Now, my name is Grace. I am a meteorologist, which basically means I study the weather, and I am tangled up. Hold on. Alright, we're good. I am a meteorologist. I study the weather. I look at the oceans and the clouds and the skies and figure out what weather we're going to have that day. Now, the weather report I'm going to be giving to you today is about Wonder Seeker Island. Now, unfortunately, on Wonder Seeker Island, we have some very extreme weather, which means I do have to do a little bit of a health and safety announcement before we get started. So, you guys here, lucky enough to be on the mats, see this white dotted line in front of you? This is our safety line. So I need bottoms, toes, nose, fingers, all behind that line at all times. I'm going to be doing some very exciting but very dangerous demonstrations up here. And as long as you're behind that line, you are nice and safe. Give me a thumbs up if you got that. Amazing. Adults, give me a thumbs up if you got that. Amazing, because you are responsible for them. Now, you can come and go as you please. That is absolutely fine. I'm not going to be offended at all. But just if you are leaving, can you make sure that you close the curtains at the back behind you? This just makes sure that any noise or light stays nicely outside the theatre and you can continue hearing my wonderful voice. Now, when you do, talking of unwanted noise and light, there will be some bright lights, some lighting changes. You'll get plenty of warning before they happen, because hopefully we'll get to see some fire. Ooh. We'll also, near the end of the show, there'll be some exciting popping noise. There are cameras at the back. Now, you guys are not, so do not try any of this at home or anywhere else for that matter. But with all that boring stuff out the way, let's begin our weather report here at Wonder Seeker Island. Now, in the north of Wonder Seeker Island, we have reports of forest fires. Now, forest fires happen because of something called the fire triangle. Now, the fire triangle was made up of three parts, like three sides of a triangle. This is how we make any fire that we want, but we're going to be specifically looking at forest fires. Does anyone know what the three parts of the fire triangle are? If you don't know all of them, one will do. Yes?
Heat, fuel, and oxygen.
Heat, fuel, and oxygen, super scientists, yes. Heat, fuel, and oxygen, all three parts of the fire triangle. So if we look to our forest fires, our fuel is the dried trees, dry branches, dry grass. They are an excellent fuel. Now, the air going around the trees, they have oxygen in it, so the air going around has oxygen in it, which provides the oxygen part of our fire triangle. And last but not least, we have the heat, which is from the sun. So with the heat from the sun, the oxygen in the air, and the dry trees, we have a perfect fire triangle, which is why we're getting forest fires in the north. Now, to create a forest fire here in Winchester Science Centre would be incredibly dangerous, but I can show you a little example of the fire triangle. Now, on here I have some sugar, which fuels me through the day. Who here is fueled by sugar? Lots of those down on the front, I see. So, this is going to be our fuel. Now, I believe there is oxygen in the air. Shall we just check? If we take a deep breath in and out, we can all breathe. That's good. There is definitely oxygen in the air. And I've got a barbecue lighter here, which is going to be our heat. Now, because I'm doing something with fire, I've got to be very careful. So I need to introduce you to the best piece of science kit ever. Give a round of applause for a stick on a stick. Woo! Now this is Stick and Stick Junior, so I'm going to light Stick Junior. to allow me to be far away from the fire as possible. Okay, so now we've got our heat and we've got our fuel, and there should still be oxygen in the air. Let's check. We can all breathe, there's still oxygen in the air. Get all three parts of our fire triangle. So we should get a fire. Are you ready? In 3, 2, 1. Oh. Did anyone see any fire? No. Right, we definitely had our heat. We had our fuel. We did have oxygen. But I've got a theory. Yes, there is oxygen all around this fuel, but the sugar particles are really small and they're all piled together. There's no oxygen on the inside of this pile of sugar. So we need to get oxygen around every single particle of sugar. Fortunately, I've got a backup plan. I've got a squeezy bottle full of sugar. Now what this does is it puts oxygen around every single particle of sugar. I could light the sugar with my barbecue lighter. That's a bit small, a bit boring. So I thought, maybe I should just use a blowtorch instead. So it's going to get a bit exciting, so I'm going to put some safety glasses on. And this is where it's going to get even more exciting because I'm going to come a little bit close to you guys. Okay, now, this more than ever, make sure your bottoms are stuck on the mats for this. We have our fuel and our oxygen, just like that, and we have our heat, like this. So hopefully we should have our fire triangle now, and we can create something that I like to call sugar flamethrower. Alright, are you ready? In 3, 2, 1. Whoa! Should we see that again? Yeah. Alright, in 3, 2, 1. And one last time. In 3, 2, 1. And there we have our fire triangle. Okay. So you might start to get the smell of burnt sugar in the air because of that little demo there. So that's kind of what's happening in the north with the fire triangle. Moving into the Midlands of Wonder Secret Island, we have very fast winds. And when those winds combine with the fires from the north, we get some fire tornadoes. Now fire tornadoes, because they have all three parts of the fire triangle with them, and they're combined with the wind. What the wind does is it's in the tornado, it picks up more and more debris as it goes around, fueling the fire tornado, and allows it to get bigger and bigger and bigger. Now fire tornadoes can be up to 10 meters to 50 meters big. That's nearly as big as the Leaning Tower of Pisa. Huge! Fortunately for us, fire tornadoes here on Earth are very rare. Not so much on Wonder Secret Island, they're quite common. And unfortunately, as much as I'd love to create a 50-meter fire tornado here in the theatre, that is also very dangerous. So, and it would be like a disastrous Wizard of the Oz. Now, what I'm going to do is I'm going to show you how it works with a little smaller version over here. So, I have this base plate, and you may notice it's got some spiraling plates going around the side. Now what this does is it shapes the air into that tornado shape. I've got what is going to be the core of our fire tornado. This is bioethanol gel. So it's just flammable gel, and it's going to go inside and be the core of our fire tornado. So let's give it a quick light. Now, I can put this glass container over the top, just like that. What that does is the hot air rises, which creates a vacuum, sucking up the cold air inside, which is heated, and then the hot air goes up. Sort of like this motion. Now, because of those plates that are spiraling up like this, it shapes the air into a spiral, creating our tornado effect. Difficult to see with all the lights on, so I'm just going to bring the lights down. And I'm going to bring them down a little bit further. And there we have our fire tornado. We've got blues near the bottom, oranges near the top, and you can see that wondrous swirling spiral pattern that we familiarise ourselves with tornadoes. And lights back up as we give it a round of applause for the fire tornado. There we go, so we've got some light now. Now, just like we can create a fire with all three parts of the fire triangle, we can get rid of one by taking away one of the parts. So if I was to take this plate over here and put it on top of our tube, what do you reckon I'm getting rid of? You don't know what I might be getting rid of? Yeah? Oxygen, absolutely. So I can take away the oxygen, and then our fire goes out. There we go. Now, moving even further south, to the south of Wonder Seeker Island, looking at this colour pattern, the blues, as you might have guessed, Wonder Seeker Island south is very cold. In fact, it is negative 78 degrees Celsius. Extremely cold. Now, at that temperature, carbon dioxide, the gas we breathe out, does something really interesting. It freezes solid. Can you imagine breathing out ice cubes? It's crazy. So frozen carbon dioxide is something called dry ice. Now I've actually got some back here as well. This is dry ice. It does something pretty interesting. Now let's just look at water for a second. Water goes from a solid to a liquid to a gas, and it goes in between those. Whereas frozen carbon dioxide or dry ice goes from a solid straight to a gas. It skips out the liquid stage completely. It is never liquid in normal circumstances. Now this process is called sublimation. Would you like to see some sublimation? Yeah? Alright, are you ready? In 3, 2, 1. Woo! It's sublimating! Whoa! What do you think? Can't see it. Is it really cool though? It's a bit boring. Should I speed up the reaction a bit? Okay. So up here I have got a glass of water. Now this water is just cold, but compared to the negative 78 degrees, this will appear boiling hot. So let's put a little bit in and see what happens. The water acts like a catalyst, speeding up the reaction. Now, the bubbling that you can see at the bottom here, this is the carbon dioxide escaping off the dry ice because it is sublimating, going straight from that solid into a gas. The stuff at the top that makes it look a little bit like a potion from Harry Potter or something like that, this is just water vapour. As you can see now, in movies and in theatres, they use this to create potion effects or spooky mist on the stage. So it's just water vapour. But have you guys ever had a fizzy drink and it fizzes your nose? Some yes, some no. Well, you may recognise this face. So, when you get that fizz in your nose, what that is the carbon dioxide going into your nose, which creates that tingling sensation. Do you want to see it again? So, it's pretty cool, but we can speed the reaction even further. So, I've got some recently boiled water, and it's going to go into cold water to give us some warm water. like that. Again, the water acts like a catalyst. Now, because it's water vapour, I'm actually going to bring it round and try to get to most of the people, but please, you can have a feel what it feels like. It's just water vapour, just try not to touch the container. We're going to come through the middle, so part the way. So careful not to ice, so there's less to react. But that will just keep bubbling away anyway. We've seen now what happens when we let it escape. What if we trapped it? So, I've got a giant bottle over here. And add some more hot water in. Okay. And I'm going to take some more dry ice. Put it inside. So you can see the carbon dioxide and water vapour escaping. But if we take a plastic cup and put it on top of it, what do you reckon is going to happen? This is where the exciting popping noise is going to be.
Oh my god!
The pressure builds until it is released at the weakest point, launching our plastic cup. Let's see that again. Couple more times. Like a dry ice cannon. So, should I do it with two this time?
Yeah!
Nearly caught it. Try, did someone say try three?
Yeah.
Should I try three?
Yeah.
Not sure.
7.
I've got an old archaic document called a risk assessment which says I can only do 3. There we go. And with that, I reckon that is even better than a snowball fight. My name has been Grace. That has been a weather report from Winchester Island. I hope you have a lovely rest of your day at Winchester Science Centre.